Let's invite the Director of Wireless Product Management Department of H3C, Mr. Liu Chen, to share with us about Wi-Fi 6 booster of new value with smart and simple O&M. Hello everyone. So my colleagues previously they have shared with you in 2020 H3C in Wi-Fi our new technology as well as our new products. Also, during their presentation, they have left a shadow. That is, in 2020, we have proposed the intelligent and simple O&M, this kind of concept. So next, I'd like to share with you, in terms of the intelligent and simple O&M, our products and solutions in this aspect. First of all, let's have a look about development history of Wi-Fi. So since 1996, IEEE they have released 802.0.2011 this kind of protocol. So actually, Wi-Fi has come into a high-speed development stage and with a high development of the technology. So the characteristic of the Wi-Fi 6, you are quite clear about that. That is the high bandwidth, the broad coverage, the low latency. And the Wi-Fi network actually compared with the cable network, it has this kind of a characteristic that cannot be interfered towards the electromagnetism. And some enterprise thinks that the twisted pair antenna would be a quite good one in fighting against the interference. So the Wi-Fi needs to guarantee its interference towards this. And for H3C, we have been engaged in this for 17 years. So today we want to talk about our understanding of the intelligent and simple O&M. So actually, for every technology revolution, they will have more and more of the content with high quality. So in the interstage of the construction of Wi-Fi, we will frequently use the text flow. We use the text to send email, to chat with each other, and to record the details of our lives. And when we come to the Wi-Fi 5 era, a large amount of the video flow business has come into our Wi-Fi era. And in the Wi-Fi 6 era, we believe that like the 720p, this kind of HD business will come into our Wi-Fi and the wireless network. So actually, like the AR and the VR, this kind of a virtual reality business will gradually become a reality in our life. So with the change in the business, actually, our terminals are also having change. So in the initial stage of the mobile network, for example, like our traditional PC, our mobile phones, so as the kind of carrier for this kind of wireless network. And currently, our smartphones, our smart computers, as well as the smart home, this kind of smart products, they gradually require to be connected to our wireless network. So more and more of the change in the terminal and the business will definitely bring new challenge for the wireless network and can be summarized as follows. First, how can we guarantee the user experience, and how can we reduce the cost of the O&M? That would be the second point. So first of all, let's have a look about how to construct a high-quality Wi-Fi 6 network. So in the initial construction of the Wi-Fi, in many of the zones, the access point of the wireless network can be put randomly, and they are many of those private routers. So many of those wireless channels might fight with each other, and the result is that we might have the dead zone in the coverage. And the final experience is that no one can really enjoy the good network service. So in our intelligent simple O&M from H3C, we propose that in the initial planning of this, how should we consider after its construction, we can have a standard acceptance, and finally to achieve intelligent as well as a simple O&M measure. So first of all, let's have a look about our traditional engineering survey as well as the current engineering survey that we need. So for the traditional engineering survey, we think that there are many pitfalls in it because usually the engineers might just take the drafts and to make the decisions according to their own experiences and to decide which police needs to be deployed with AP, so there is not a standard in this whole procedure. How about the acceptance? So they will just use their own laptop to open a kind of video app. So in those kind of zones with Wi-Fi, and they might watch the video while they are walking. So they want to do the acceptance mainly through whether the video is quite fluent. So this is the traditional engineering and survey. We have found that actually 20% of the failures of the network comes from the non-standard acceptance, and we also found that among those 20% of those failures, 10% of the equipment failures actually might result from the acceptance, which is not standard. And this is a waste of our time and money as well as the human power. So for our smart engineering survey, we will have an online simulating coverage to have an on-site big data simulation and to eliminate the blind spots. And also in terms of the acceptance procedure, so based on the air interface technology and many of the other technologies, to do a kind of standard and procedural acceptance to make this network quite clear in terms of its usage. And our smart engineering survey, compared with the traditional acceptance, actually they are a solid foundation to build this kind of high-quality wireless network. As we have talked about the engineering survey and our acceptance, and now let's have a look about the traditional O&M, actually, which it is a quite passive, low efficient one, and which requires the huge accumulation of the professional knowledge. So to put it simply, our IT O&M staff. So during the scenario of the large amount and the high frequent complaint received from the users, they cannot have a very simple and quick judgment of the problems. Most of the time, they need to judge the whole network to find the source of the problem. So actually, this is quite time-consuming and might easily influence the whole network. So this very simple kind of operation in the network might cause the interruption of the whole business. So if the business has been interrupted, let alone about the good user experience. So for our intelligent and simple O&M, by accumulating the terminal information combined with the big data algorithm, we can do the network slicing. In order to guarantee the uninterrupted business of this network, we cannot have a leapfrog measure. We only need to we can only just do it slowly to solve the problems in different phases, to have a diagnosis in different sections, to gradually optimize the slices, to avoid the interruption of the business, which might cause an irreversible damage for the network or production. So that is the kind of concept we have proposed of the non-invasive smart healing. So what are the features of this non-invasive smart healing? First, the feature would be the accurate identification. The commonly seen problem of the Wi-Fi can be divided into 4 parts. First is that the wireless network cannot be accessed. Second would be the weak signal. And third one is that they cannot go online. And fourth one would be the low latency. And through the all-round user analysis to find the kind of terminals which has the anomaly, which have the anomaly of the authentication and the correlation, and also through the all-round air interface analysis to find the source of the interference and the weak signal. Together with our original Dr. AP technology, we can have an analysis of the business to simulate the business of the users to detect the internet anomaly, and also together with the big data model to analyze the problems in the network and to finally find the source of that. So actually to find the root cause would be the basis for us to solve the problems of the network. And the second characteristic would be our smart tuning. For example, once we've started an AP, it will randomly select and be connected to an internet channel, and through this channel, it will provide a wireless service. If the adjacent AP happens to choose the same channel, then we will see the problem of the same channel interference, which means that without providing service for the users, these wireless network within it, these adjacent AP are fighting with each other. So we cannot provide a good service for our users in this regard. By the simultaneous and the real-time monitoring of the network, of the channels and the frequency, so that our wireless network can always be kept in the best status, and to finally achieve the smart tuning, and we can improve the comprehensive performance of this network of 35%. We have talked about our two characteristics. Finally, we need to achieve the non-invasive smart healing. For example, in one university in the southwest China, we have provided the smart and intelligent O&M service for them. We have communicated with the faculties and the students there. They found that the concept of the intelligent simple O&M from H3C is quite effective for them to monitor the network performance. But one problem they found is that once they have seen any problems in the network, they don't dare to click any button in the intelligent and simple O&M system, because they fear that once they have a click that, the whole network might be influenced, and there might be interference in the business of this network. So most of the users might worry that the optimization might lead to the stagnation of the business. And for our H3C intelligent and simple O&M, actually we have done a slices of this network, for example, for our meeting room, an experience center, and an exhibition hall. So for all of these businesses, we can then do the slices of them. When there are problems in these different sections, we only need to optimize the business in this small section. And once we have achieved a good optimization of this small section, we can gradually improve and optimize the whole network. And this is quite a good steady state. And finally, we can achieve the result that the quality can be gradually improved without the interruption of the business. And what are the values brought from the intelligent and simple O&M? Actually, for our end user, we have improved the experience for them. For our IT staff, they can reduce the kind of complaint they've received has been lowered and can emancipate their productivity force. And for the investors of this system, they can reduce their cost in this. And actually, in the construction procedure, all of the things can be optimized. How can we reduce the O&M cost? I'd like to cite another example with you. Also, the network service team in a university in the southwest China. So actually, previously, there were over 5,000 AP to provide services for the faculties and the students. Before the usage of our system, there were 3 teachers with 10 students to do the O&M work of this network. with the increase of the access users, and they receive more and more complaints. So for quite a long time, they receive a large amount of the complaint phone calls to solve the similar problems, but they cannot find a good solution. But after they use our system, they found out that they don't need to just track the information of so many users, and this network has become more and more easy to be controlled. Because previously, the students and teachers need to take a long time to receive these phone calls, and now one teacher together with 3 students, they can just monitor the scenario of the network on their own personal computers, as well as the equipment status. So this has not only enhanced the experience, but also has reduced the input of the human power and has provided more people the good efficiency of operating and maintaining their network. And so far, over 2 million equipments are enjoying our intelligent and simple O&M service. So we hope that in the future we can provide services for more and more scenarios and more industries. So first, we can have a look about the production network. We know that actually this is the kind of network that we frequently see the problems of the same channel interference as well as the adjacent channel interference. They don't have a standard deployment method, and users are different. So in this kind of circumstance, the interference is quite frequent. So through the air interface equilibrium, we can balance the AP accessed users, and by optimizing the channels to reduce interference. And we found out that through these 2 technologies, actually we can reduce 25% of the interference of the production network and can increase the transmission efficiency of 30%. And in terms of the office network, they will have more and more of the real-time business like the video, the audio, and the projection screen. So these will definitely have higher requirement of the stability of the access. So by guaranteeing the business flow as well as the air interface dynamic equilibrium, we can improve the quality of the air interface of 40% and greatly enhance the experience. And in terms of the healthcare and the university, this kind of large-scale zone network, they are diversified terminals that will be accessed into the wireless network. Apart from the mobile phones and the PCs, also we will have the kind of new equipments like the healthcare PDA, the smart car recharge machine, and the self-service machine. So for these kind of scenarios, they might different kind of channels needs to be accessed to different network according to different business demand. For example, the healthcare PDA might be accessed into the internal network of the healthcare, and the self-service machine might be accessed to the campus internal network. For this kind of scenarios, apart from considering the experience, we also need to consider about the internet roaming and the security of the access. So for our intelligent and simple O&M, we can greatly improve the roaming quality and greatly enhance the security of the zone network. By 2020, so in the IDC report of the W line of the Chinese enterprises products, so actually our H3C has been ranked top for 11 consecutive years. We hope that more and more users can enjoy our services, and more of our technologies and products can be integrated into your life and experience. So We always want to achieve the best and want to provide the best service experience to our users. So we think that with the change of the business, we can provide better experience and service for our clients. Now let's start from the intelligent change. Thank you.